I wanted to look into logarithms to see what I could learn. And I also wanted to see if I could prove that the exponent of a logarithm, in this case this exponent, will always go out in front no matter what. I'm going to use some messy numbers here, primes, just to make it a little more complicated. So log base 3 of 7 equals approximately 1.77. That means 3 to the 1.77 will equal 7. But I found out what we can do here. Since 7 equals 3 to the 1.77, that means I can replace this 7 right here with 3 to the 1.77. So now it looks like this. 3 to the 1.77, which is 3 to the 1.77, will equal 3 to the 1.77. And what this means is that this exponent right here will always match the answer right there. So now since this 1.77 will always match this 1.77, then that means this part right here would have to be 1. So what you do is just bring this part down right here, and you got 1.77 log base 3 of 3 equals 1.77. A little review right here on logarithms. Log base 3 of 3, that means 3 to the first power equals 3. This whole thing here equals 1. So this whole thing right here becomes 1, and you get 1.77 equals 1.77. Next up, I want to prove that the exponent goes out in front when the argument that's inside the logarithm is different than the base. So for example, what happens here if this 7 has an exponent? I want to prove that an exponent of this 7 right here would still go out in front, even though the 7 is different than the base, because right here I made the argument right here, which is the part inside the logarithm. I made that argument the same as the base. So what about when the argument is different than the base? So once we've established 3 to the 1.77 equals 7, then that means I can still just turn this 7 into a 3 to the 1.77, take that whole thing to an exponent of, say, 2. I'm going to be using numbers in this video instead of letters. Letters are good for a generalization, but sometimes to understand things, it's nice to use numbers. So what does this equal right here? 3 to the x power will equal 3 to the 1.77, quantity to the second power. Using your exponent rules means you just multiply this by that. I did a video on the rules of exponents and the logic behind all the rules, so you can see that if you're interested. So what this means now, that 1.77 becomes 1.77 times 2. And again, what we've done here is we've made our exponent match our result right there. So what that means is this whole thing right here can come out in front, and you'll have the 1.77 times 2 times log base 3 of 3, and again this will equal 1. So you just got 1.77 times 2 will equal 1.77 times 2. So this shows that the exponent can always go out in front of your logarithm, whether your argument inside the logarithm is the same as your base, or whether the argument is different than your base. And that is because no matter what your argument is, in this case it's 7, you can take your base to a certain exponent to get the same result as the argument. And thus you can always turn your argument into your base.